Okay, my name is Young, and today we have a customer spotlight webinar on automating DevOps container security practices at Cooperators Insurance. Thank you again for your attendance, and I'll go ahead and hand this off to Glenn Kosaka, our Vice President of Product Management. Glenn, would you like to take it from here and also introduce our customer and guest speaker at IBM Cloud?
Yeah, thank you. Thank you very much, Young. And thank you everyone for joining us today, this morning. So today you're going to hear an interesting real life story from Niteen Kole, who has not only implemented containers and container security into the pipeline at Cooperators, but also done the detailed work of automating the entire process, or as much of the process that is possible. So it's a very exciting story and a journey that Niteen has been on. We're also, since Niteen and Cooperators are running their container workloads on IBM Cloud, we're also going to hear from Chris Rosen, who is a program director for IBM Cloud. So before we jump into Niteen's, before I hand it over to Niteen to talk about his story, I wanted to cover a couple things. The first is I'm going to talk about some of the threat landscape that you should be concerned about in the pipeline, the attack surface for containers. And then because Niteen is going to be talking about his workflow and security and how he's integrated NeuVector, I'm going to give a really short summary, one slide on some background on NeuVector, so you have that context. All right, so if we look at the typical pipeline for that many of you are trying to create and automate, it starts on the left side with the developer building the software or the microservices, and then putting them and building them into an image, and that being stored into a registry, and then it flows all the way down the pipeline into the production environment. So one of the first security concerns is, of course, vulnerabilities. How do we handle those and how do we detect those? Keep in mind that vulnerabilities can be introduced at any point in that entire pipeline, all the way into production. So from whether it's if you're using open source, or after you've stored your images in a registry, vulnerabilities can be disclosed and discovered. All the way into production. You could have running containers, and then all of a sudden there are vulnerabilities detected or discovered in those. In addition, you don't want, the whole goal of this automated CI/CD pipeline is really to improve the pace and shorten the cycle of releasing or updating services and applications. So you don't want security to slow or break that pipeline, to stop it saying, oh, whoa, we need to analyze this application, we need to come up with security rules, and it's going to take us a couple days to request those changes. So that's another key concern. Now, misconfigurations, whether it's in registries or your orchestrator or the hosts themselves, can also leave your infrastructure open to attack, as the well-publicized Tesla hack that was done on a Kubernetes console to install crypto mining software a couple years ago. Now, in the production environment, there's also new attack surfaces. So you've got your orchestrator, Kubernetes, your Docker runtime, other tools that you're using to manage your containers all become a new attack surface. And, in the scope of IT, those are fairly new, even though they're in production. There's a lot of production instances, but hackers have still yet to get their hands on widespread production deployments and find all the ways to try to exploit the tools. And then, of course, the last one is the typical application attack surface. How can hackers get in? whether it's exploiting a vulnerability, a zero-day attack, insider attacks, all of those things are still potentially could still happen in a container environment just like they could in the past. So with that, what NeuVector provides is really what we call full lifecycle security. It starts with the build phase where we can use Jenkins plugins or extensions to all of the build tools to trigger a scan and kick that back to the developer if it's got too many vulnerabilities. And then once you put the images in a registry, the registries can be continually scanned for vulnerabilities. And that extends into the runtime environment with runtime scanning and CIS benchmark audits, as well as vulnerability management, reporting, and alerting. Now, as you're deploying your workloads, I think you'll hear from Niteen as to how he's using this new concept of security as code and actually being able to specify the runtime security policies in Kubernetes-friendly YAML files and push those into the production environment. Admission controls are provided to make sure that only authorized images and images without vulnerabilities are allowed into the production environment. And then finally, NeuVector provides the industry's only container firewall, layer 7 container firewall, to monitor all the pod-to-pod traffic, as well as the ingress and egress network protections. In addition to that, NeuVector inspects every container workload for processes and files that should be allowed or blocked, and can enforce policy on those as well. And there's a full set of packet capturing, alerting, forensic response that can be quarantine. All of those things can be done in the runtime environment. All right, so that's a quick overview of NeuVector to give you some context. So with that, I'm going to switch the presenter over to Niteen and let Niteen take it away and tell his story.
Yeah, it's my pleasure to share our experience at NeuVector as a container security in our environment. Our journey started almost a year back when we wanted to operationalize our containerized environment. Security was one of the key three criteria for us to go live before go live. So this is my agenda for basic requirement for container security. Challenge is selecting tools. How did we operationalize our security tool? And then the next phase is policy as a code or starting with CRD. What were our basic requirements for container security? Like, for example, the first one was, can we scan each image before it's get deployed? Like, any image which goes inside our Kubernetes cluster, inside our deployment, it has to be scanned. So we don't want to allow any image to go inside deployment without it get scanned. Second thing was like, can we restrict or have control on image registries? Like example, at this stage, we know that we can have multiple registries, private, public, IBM, Azure, you name it, we can store our images. Our main concern was, how do we control or how do we restrict pulling images or getting deployed to our cluster only from certain registries? This was basically for operational efficiency. And then it's very easy to manage few registries other than allowing everything else, because it's difficult to go through process control and all. So one of the requirements was restricting pulling of images from certain registries only. And then the main thing was, how do we make sure our environment has minimum number of CVs? We know that CVs you can have CVs in your running container, whatever it is. But main concern was, how do we minimize number of CVs in our environment? Next critical thing was, once we have a clean image goes into deployment, now how do we make sure whatever inside image, how do we take care of, how do we control the process running inside container? For example, we scan our image is clean, goes into deployment. Next is what is inside images. Like example, say image has telnet process or nmap or whatever it is, how do we control from a security point of view? Like allow only certain process, block other process. How do we take care of that thing? And then the main thing, for example, to deploy image, clean, goes into production. Now we don't want anybody to exe to our container or do on the fly changes. Like for example, you exe to your running container, you do some VI, you do RM, or for example, if you have say alpha image, you exe then say APK add, whatever you want. We don't want all these things to happen in our production environment. And then the main thing was whatever our requirement are there, how do we integrate to our existing CI/CD process? Doesn't matter it is say IBM tool change or Azure or Jenkins or whatever it is. Whatever the security tool we will use, it should fit into that process. And at the same time, we don't want to do any manual changes. Like for example, we want to reduce any manual changes as minimum as possible. Now, just to give a background, we started operationalizing or starting a containerized environment a year back. We started with IBM managed Kubernetes clusters along with AKS. And then our first goal was to find a security tool. So initially, we started using all the major container security vendors available in market. We compared them. We ran POC for a month. We compared them for each features, operational availability, how flexible it is, what features we can add to that. We compared everything and we shortlisted few of them. Then the main question was, why did we select NeuVector? So if you see the previous slides, we had basic requirement to start or to convert our environment to an operational environment along with security. All those major things were available in NeuVector, plus few things were not there, which we took back to NeuVector saying that, okay, we want these things. How flexible you are to develop these things. So those things were there. We took all those things to other vendors also. At the same time, our main goal was to have an enterprise tool, platform independent. Like for example, it should not be tied up closely to say IBM managed Kubernetes cluster or say AWS or Azure. We want something which is platform independent. We want to have certain like security tool which is enterprise level. If it works for say Kubernetes, IBM Kubernetes managed cluster, we should be able to use same thing for our other environment so that we have enterprise level, a single tool which can manage all our containerized environment. Now, other main thing was that if you see at this stage, like managed clusters, which are like say IBM or say Azure, IBM managed Kubernetes cluster runs on say container DS runtime. Azure works on Docker runtime. So we want to make sure that whatever tool we select has to be compatible irrespective of what container environment or what runtime environment we use. And then the main last factor was the cost effective. So when we started initially a year back, we didn't have much applications. We want to make sure that we start small and horizontally scale. So most of the vendor came back saying that for with respect to licensing, how much you want, 6 months, 1 year. We were not sure we want say 6 nodes or 20 nodes or 30 nodes, or some vendors came back saying that we license as per the pods. We were not sure. So our main goal was to start small, scale it horizontally as increase, and then at the same time, we increase our licensing accordingly. Now, let me give you a practical example how we automate or how we took NeuVector as a security tool and add it to our normal CI/CD business. Developer build an image. As I said, we want to control few registries so that it's operational efficiency. At the same time, we give 100% freedom to developers. You build your image from wherever you want to build, whatever your base image is there is no restriction. But one thing is, once you build your image, it has to be pushed to private registry, which it has set up in NeuVector. Like for example, at this stage, we have IBM registries, private registry, and Azure private registry is set up in our NeuVector. So any developer who wants to develop his image, he or she has to push his image in private registry. The NeuVector is set up to scan, say, every 5 minutes. So whenever image is pushed into a private registry, NeuVector automatically scans it. The schedule scan is either you schedule it every 5 minutes, which is default, or you can scan it using API or a trigger your scan. So the first stage was there. Developer develops image, push it to private registry, NeuVector scans. Now let's take a practical example. A developer wants to deploy his image in a Kubernetes cluster. Here also we made sure that there is no restriction on what toolchain you use. There is no dependency. There should not be any dependency. You can use plugins. NeuVector plugins, you're using Jenkins, you have Jenkins plugins. If you don't want to use plugin, you can use API. If you don't want to use API endpoint, you can use CLI. So there is no restrictions. And then each application has access to NeuVector. For example, they push their image. NeuVector has full details of his image, his or her image. You can initiate developer in that stage triggers a scan. You can have a manual scan. You can have scan using API or whatever method you use. Your image gets scanned, and then you get the result. Now, one simple example is like, for example, is like we allow only images from private registry. So that has to be passed. Second simple admission control rule is that we make sure that if your image has high CVE with vendor fix, it will not be allowed to go in deployment. So all this admission controls or whatever the policies we have defined is given to our developers or the application team saying that you have to fulfill this. So if this policy or whatever, like for example, say an image is deployed, development is trying to push that image, and that image has a high CVE vendor fix, it's not allowed. So they have the scan results, they can validate. If it fails, goes back, you have to refix it, and the cycle continues. If this pass, then it gets deployed. So if you say this, there is hardly any involvement of operational security. Security is involved during only one stage when you define the policies, when you define your policy saying that this registries are allowed or this admission controls are allowed. They're involved at that stage only. Otherwise, it's like the same automatic cycle. Developers, if the image is clean, if you pass all your admission controls, it gets further. Only one thing now, this happened. Only one thing from our learning, what we learn is that moment, for example, say your image is clean, it passed and went into deployment. Now it's up and running. Now, say every day we have CVE update running inside our cluster. So your CVE database is updated. And at the same time, once CVE database is updated, all your running containers are rescanned to see if it has new CVEs or not. Now, what happens is that, like example, say your running container has a new CVE, say high vendor fix. So for whatever reason, if it restarts, the admission controls will block it. So how do we take care of such situation? What we do is that we have automize whatever the scan results are there. That scan results, we take the results and whatever the results are there, we send automatic alerts to owner of the image. At the same time, alert goes to our security tool. So anything happens to a running container or a runtime environment, we get alert. So in that process also, the owner gets alert. At the same time, security team gets alert.
Hey, Niteen, a couple questions have come up. Is it okay if I ask you a couple questions at this point?
Yeah, sure.
Okay. So how long did it take to develop this whole automated process and workflow?
Yeah, so initially it took us around 3 to 6 months because everything was new, and then we need to try all the trial and errors, and then, like for example, some features were not there in the tool itself. Like for example, say our aim was to make sure that when we build the image itself, it should have minimum number of CVs other than to fix it. So we went back to NeuVector saying that we want this admission control rules to be put in place. Like for example, if any image is high CV, say with the CV level 5, it should and it has a vendor fix. We want that thing. So we went back to NeuVector. They put that thing in place. So around 3 to 4 months of initial trial, and then we went in operation production. Now everything's running in production.
Mm-hmm. Yeah, so there's probably some testing and adjustment, and then it sounds like you requested some features from NeuVector, like the admission control. If there's a vendor fix available, then allow it. No, don't allow it or block it. And then if there's no vendor fix, then allow it.
Yes, and also it depends on the tool chain which you use. It depends, like if you use IBM tool chain or Jenkins and whatever it is. So yeah, depends on application size.
Okay. Another question is on the notification that send alerts part of it. And you mentioned notifying the owner or developer. How do you identify who to notify and then do it automatically?
Yes, so as I said initially, we don't want to do anything manual. So what happens is that when you build your image, you have an author field. So in your author field, you can mention whatever the email ID or whatever ID you want. But few weeks back, the author field is deprecated, and now you have to use a label. Like for example, when in your build Docker file, you can specify label, maintainer, and the email ID. So what we do is that we have the scan because NeuVector, whenever the CV update happens, NeuVector scans all the running images and it has the data. So we have optimized to get say details of that image, and then from that you can use Docker inspect image because we know the image ID of a running container, and then you get from the label maintainer field you get the email ID. So the process itself, it checks each image from the scan. We now have the email ID of the owner of that image. It sends, if that is, say, anything which is not as per our admission control, it sends automatic alert to the owner of that image. At the same time, it sends a CC to whoever wants that security. So that itself, there is no involvement in operations or manual to do anything manually.
Okay, yeah, so it sounds like everything is automated. And how do you handle exceptions then?
Yes, yeah. So what happens is like, say for example, I can give you an example. When we didn't have this kind of admission control, or we didn't have any rules in our Kubernetes environment, the images which was developed initially like had almost more than 400 CVs with vendor fix. So there were a situation where where developer came saying that okay, we want an exception because we cannot fix it. So there is a process, but developer or whoever owns the application has to justify to a security tool. Like for example, if you want to put exception saying that okay, this CV is there with the vendor fix and we need to put exception. So we have a ticketing process which goes, but main thing is they need to justify why you need to put exception. Uh, like for example, you can go in admission control, put exception whatever you want, but from like from my experience using this for the last 1 year, like for example, say vendor fix CV with high vendor fix, if we allow that, all the 400 CV image with 400 CV would have passed to the and will be up and running. It would have been very difficult for operation to chase manually or go behind and then tell them to fix. So our thought process was, okay, you fix it at the source, whatever possible, and if you want say exception, you justify to our security saying that why this needs to be allowed. And from my experience, as of now, we saw only one exception, and that too because there was a lockdown or a production change freeze for a week, and then. But there is an option you can go in admission control if say exception is required or is valid, you can do that.
Yeah. So that's good that it's not, you're not getting hundreds of exceptions. And so it sounds like you've really matured your process. I'm gonna take one more question and then let you continue since we're on this topic. And then for others, please continue to send your questions in and we'll ask them as we go along. This one's from Louise. How do you rank vulnerabilities? You know, how do you decide which ones need to be fixed? And then he had a follow-on, which is, you know, if there are thousands of vulnerabilities, it can be tough to go through them.
Correct. So what happens is that, say, so we use the basic thumb rule. So for example, any CVE with high vendor fix and any high CVE with vendor fix. So now you know that you have to fix it because there is fix available. So that there is no exception that you cannot say that I don't have time or whatever reason. You know there is a CVE and it is high. It has a vendor fix. You go ahead and fix it. So that's the thumb rule we use it. So if you, for example, if with that thumb rule, at this stage, all our environment, all our images running in, even in non-production, doesn't have any high CV with vendor fix. So that takes care of all. Now, if you have say high CV and there is no fix, there is no option. Our thought process, our security thought process was that okay, you have a high CV and NeuVector, like when NeuVector scans, it says that okay, you have a high CV. This is a CV and this is fixed for that. So you know that there is a fix available there. If fix available is there, what is stopping not to apply? So So what happens was that we had a lot of resistance from our developers saying that we don't have time or why we need to fix it. But again, security went back saying that okay, our scan says that you have a CVE, you have a fix for that. Why you're not ready to fix it, or what is the reason not to apply that fix?
Right.
At the same time,
Go ahead. Yeah.
Yeah, at the same time, if you see the NeuVector scanning, you get the severity level. Like, for example, high CVE with say, severity level 1, then 2, 3, 4, 10. So the question is how we detect what severity level needs to be fixed first. So if you don't have this admission control, then you can go back saying that, okay, my image has high CVE with severity level 10. Go ahead and fix that first. And then it has from 10 to 1 severity level of details. You can use that. You can use that method also.
Great. All right. Thanks. Anything else you want to mention on this automated workflow before you continue?
This was our basic in respect to CV thing. Yeah, I don't think so I have anything else. Yeah.
Okay.
Yeah. Now the next thing is like, for example, say today there is say CV, say high CV with say severity level 10 and it's creating havoc on internet. Now enterprise security come back to operations saying that okay, we have this high CV. What is the impact on our environment? Like what impact we have on our applications running as a container? How we get that data? Few months back, it was very difficult. Like for example, with this tool or any other tool, also you have to go at a container level, get the report, see which running image has this CV and all. I think at this stage, NeuVector is a nice feature. Like you take the CV number, put it in filter, it shows you what impact you have. I think Gran, if you want, you can throw more light on this.
Yeah, I mean, you can see the with fix, without fix. That was a feature requested by Niteen to add that not only to the analysis, but also the admission control, as well as this reporting that you're seeing here. You can filter by that, as well as severity and namespace or node and things like that. And then the impact that Niteen mentioned is the bottom arrow, where for any specific vulnerability, you can see which production environment is impacted, as well as which images that CVE exists in. So you get a list of images, hosts that it's impacting, as well as running containers. And the color coding is green, meaning that's high vulnerability is running in production. However, green means that you've turned on the NeuVector runtime protections for those workloads or those hosts, and that means that you, I guess that term there, virtual patching, really means that even though there is a CVE in that running container and you haven't actually patched that CVE, you've virtually patched it by turning on network, process, and file system monitoring and protection in NeuVector. However, the ones that are in red are unprotected, so you need to turn on those protections. So it's just an easy way to figure out your risk of being exploited in the runtime environment.
Thank you, Glenn. Yeah, now what next? Now, for example, we have a clean image goes into deployment. Now, next was like, how do we control what is running inside image? Like the image scan, initial image scan will not detect what is there inside your image. Like for example, say image is clean, no CVEs, goes into deployment, up and running. Now, how do we make sure what is inside that image? Like only like how do we make sure only required processes are running inside that image? Like for example, developer develops an image, it's clean, and by default it has a telnet process or it has a SSD process running. It passes the first stage, goes into deployment because it doesn't have any high CVEs or like that. It goes in deployment, it's up and running. But ideally, we don't want such process to be running, or we don't want anybody to. Like for other thing is that your image is your deployment is up and running. Somebody goes exe into that, and then say if it is alpine, you do alpine add and say tell them you alpine add whatever is required because everything is passed. How do we take care of in other words, how do we take care of a running container? How do we make sure that only required thing is running inside our running containers? So at the same time, we don't want to manage all this manual. Like for example, at this stage we have say 40 to 50 application as a containerized running. We don't want to put additional operational headache on each team saying that you go and check in each image. We don't want to go that route. So what at this stage we do is that moment image is clean, allowed to deploy, it goes into deployment. So moment it gets deployed, NeuVector as a security tool scans everything for that container. It scans the network endpoints, it scans the number of processes running, it scans which processes is running, it scans the network connectivity, it scans the file system, and everything is ready. Like it discloses everything, and all the rules, everything is created and it's ready. The next is before we lock down these things, we put it into a monitoring state. Like example, there might be situations where required process not might be detected. Like for example, you leave some process and it might not be detected. So before locking it, we want to make sure that all our endpoints or all our application is as required. So moment we put it in monitoring, anything such things get detected and get alerts. So we go back and fix that thing or see why it is not restored. And then the last thing what happens is that moment the monitoring happens, we know that everything is clean, we trigger it into protect. Protect mode is like whatever is discovered in initial stage, only that is allowed. For example, say I have a alpine image up and running, it is in protect mode. Now I try to exe to that, and so even if I say ls to that, if that was not discovered, it will block it. Even if I try to now VI to that or CP to that, CP to that, everything will be denied and only required whatever was initially discovered will be allowed. So you are running your container in kind of a lock mode. And all these things we do using the API endpoint trigger, discover, run a discover is moment done. We trigger it using API endpoints to monitor and from monitor. Now, if you see this is a clean process. We have a clean images running, goes into deployment. We know now of the process, we know that, and then we lock it. But what happens is that I can give you a simple example. Let's say a clean image gets deployed into deployment, up and running. It gets discovered, monitored, and then protected. Now say, what if you have a process which is unwanted, like for example, telnet process, or during discovery, say, if somebody goes and try to CP or VR, the discovery process itself will think that it's required and you're going to get locked. So how do we take care of such situations? Because this is where, like for example, we need to, instead of uh, taking care of individual container processes or individual application processes or networking, how do we have or how do we control at a cluster level or at a global level, define a policy saying that, okay, irrespective of your image, whatever it is, you have telnet, whatever unwanted thing, you want to define at a cluster level saying that none of the image none of the image should run, say, none of the image should run SCP. None of the image should be allowed to SSH from external to these things. So how do we take care of this? This is where the CRD comes into picture. So, like for example, we took this thing back to NeuVector saying that, okay, you have a discovery, you have a monitor, you have a protect. But what if unwanted processes get detected and then it's get locked? How do we take care of these things? At the same time, our thought process was like, okay, we can do this thing in non-production. How do we take care of this thing in production? Production, we don't want to run something like discovery, monitor, and protect. We want to run production in a lock mode. Like for example, our toolchain itself, the final image, what is clean and tested in the non-production, goes to the next stage as a production. So in production, we don't require something to run as a discovery and all. How do we take care of at a cluster level? So this is where NeuVector came back saying that, okay, this is how you can do using CRD. This is how you can do at a global level. It is like, for example, you can define the policy at a global, at a cluster level saying that none of my applications should have or will run processes which you don't want. So this is where the CRD comes into picture. Simple example is that in the production environment, we don't want anybody to SCP from anywhere to our containers, or we don't want anybody to telnet from container to outside, or we don't want anybody to FTP to our container. We don't want anybody to say go and VIA or do anything to do with these things. This is where what we do at using CRD. We have something called a deploy policy at a global or a global security policy, which where we define saying that example is like for simple example is this. From like for example, from any of our container, say if you have connectivity back to outside, and say if you want to talk to a port say HTTP using port 8, we don't allow because we want to make sure that our environment is much more secure. This is a simple example where you can egress or ingress, whatever it is, you can control that way also. At the same time, you should see the second example. We don't allow anybody to SCP from container to outside or from outside to any of our applications. And this is done at the cluster level, at a global level. This is not at each application level. So we know that we have defined policies, we define processes. This is only allowed. No,
just as a background for people that are not as familiar with this CRD that Niteen's talking about, it's a Kubernetes, it's called a custom resource definition, which is a type of resource you can define in Kubernetes. And so we've implemented the NeuVector security rule, which is a CRD, to enable you to essentially deploy those YAML files like the one that Niteen just showed. And your security policy is specified in that Kubernetes native YAML file. If you'd like more information on that, we have a couple blog posts on security policy as code. Okay, go ahead, Niteen.
Yes. Now, next thing is that when we initially started, we didn't have say next generation firewall in front of our clusters. Now, if you say only taking control of your CV of images or the process is not enough in that situation. Like for example, if you don't have say costly new generation firewall in front of your cluster, you have to take care of your say ingress, egress and all. So using CRD, everything is possible. At the same time, we can see that we don't want to say manually sit and create all, like simple example. See, you're running a financial application in one container as a container is in one namespace. You don't want that namespace to talk to any other namespace, or you want that namespace to talk to only required other applications within the cluster itself. No, you can sit and write down Calico policies and all, but we don't, like in that case, the operations team need to understand the application in and out, needs to understand what are your endpoints. It's a huge manual, or technically it can be done. But as I said, we don't want to land up in such manual process. So what we do is that moment it is discovered, you put it in a discovery, you have all the policies, all the rules defined, generated. Now you take those, convert into CRDs, validate it, and then just apply it. So our operation doesn't know in and out of the applications. You like, for example, the requirement comes saying that, okay, this is the namespace, these are the endpoint, this is namespace needs to talk to, say, other namespace, or this namespace should not talk to any other namespace. Okay, that requirement comes, we export that thing as a CRD and just apply to that namespace. That's it. It's that simple process. Now with CRD, it opens all these options. If you don't have next generation firewall in front of you, like controlling ingress, egress, and all that. Now, that, as I said, we started a year back. There were a lot of learnings. For example, as everybody knows that Kubernetes is platform independent, and like it's open source same or managed, it's almost same. But when you try to integrate any of the security tool with your cluster, you need to make sure that you understand how your security tool gets integrated to your Kubernetes cluster. Simple example is, say, IBM Kubernetes cluster. Now, moment you enable admission control in your environment, inside your cluster, it becomes the central part of your cluster. So anything happens to admission control, your full cluster will get locked down. So you need to make sure that you understand what is the workflow, how admission control takes care of your cluster. For example, we had a situation where our admission control got locked. Now nothing got deployed, so everything gets locked. So we had to go back to IBM. We had to go back to NeuVector engineer and try to understand how admission control controls full cluster, or what is the workflow, what are the critical components which is required for admission control to talk to Kubernetes. Like example, the way admission control works inside IBM managed Kubernetes cluster is different from the way admission control works in Azure AKS. Like for example, IBM does your admission control, the NeuVector admission control will talk to the VPN pod of your IBM Kubernetes cluster, and VPN pod will talk back to your master folder. So you need to understand the flow. Or there is other options which vendor is, like for example, in case of IBM, you don't want to use the VPN pod method. You have other option of using, say, private load balance and use the admission control that way. So you need to make sure that how we integrate or how your security tool talks to your cluster is most critical thing. And then our next step is, as I said, is like wherever possible, we want to reduce anything manual. Like for example, as I said, we don't want to run our production into discovery, discovery monitor and this thing. So we want to integrate that thing at a global level in our tool itself. Like all the policies should be pulled inside our tool chain and as per requirement get pushed. There were few other things, but which has a global impact. Like for example, when we started, we had say few images in hundreds. They were not much. So what happens is that as you grow, the number of images goes on increasing, and scanning of each image is much more critical. Like for example, NeuVector has to scan each image. When it was in hundreds, we were okay, but when it grows now, we have in thousands. So your scanning time increases. Moment your scanning time increases, you have a cascaded impact on your deployment. Like for example, your deployment triggers your scan. Instead of 5 minutes, now it takes say 18 minutes. Everything will be impacted. So there are two aspects here. First thing is, like from our learning, first thing is from the image registry itself. Like, for example, as a developer, I'm going to push images, create a new image, stack push it. So there should be a control. Like, for example, one of our application, single application had more than 1,000 images. So we were like, and then it was NeuVector was scanning all the unwanted images. So that was one of our main concerns. Like, how do we restrict number of images at the registry itself? So, like, for example, IBM has option to define a policy at registry level, saying that okay, your images in your namespace should have, we allow only 50. Above 50, it automatically gets deleted. So we don't want to follow manual process going back to clean up and all that thing. And in case of say Azure, they have number of days you can keep images. So this makes our scanning process smooth. And we know that images, unwanted images will automatically get deleted as per the policy at the register level. And at the same time, our scanning process is efficient. Now, as I said, we were in hundreds, now it went in thousands and still growing. And there are certain requirement as per the audit or whatever requirement, we just can't go and delete images. So we had to have a process where we can increase, say for example, presently we are scanning and say we have 1,000 images. So we increase from 1,000 to 1,500. Now we need to have another method of how do we take care of scanning at a cluster level or using our security tool. So we put that thing to NeuVector. NeuVector came back. Now they have a parallel scan. Like for example, I have 500 images. I can have a scanner which is a two instance of a scanner. Now I need say more parallel scanning to happen. I can just scale my scanning parts from say 2 to 4, and this will automatically take care of my number. If I have to scan say thousands of images, I can increase my parallel scanning as required. And then another learning was like, for example, when we initially started building, destroying, it's very difficult to, like, for example, when we build NeuVector, it becomes hard. We want to keep all the scanning results, all the policies, all the rules, everything intact. Like, for example, if I destroy my cluster today, I want to rebuild it, parallel rebuild somewhere else or rebuild a new cluster. Our requirement was like, okay, we don't want to put much more manual efforts and rebuilding and all that thing. Now, the way we do is like, we connect object storage to our NeuVector, and NeuVector internally takes regular backup of all the configuration, all the scanning results, and it's available in the object storage. Like for example, at this stage, if something happens to my cluster, I have to rebuild it somewhere else. I just have to deploy all the deployment with respect to NeuVector and connect the same object storage as a PVC in backend. Within 5 minutes, I have same setup, same policies, same everything as required, which was running in original cluster. Only difference is that we need to point the DNS to our management console. That's the only time. Otherwise, we don't have to do anything manually. Redeploy it, connect the same objects, and we are fine. Yeah, I think that's it from my side. Thanks.
Great. Thank you so much, Niteen. That was a really good overview, and the journey was a really interesting journey. So I'm going to now turn it over to Chris Rosen to talk about IBM Cloud. Chris, we've got about 9 minutes to the top of the hour, and we do want to, there's a couple of good questions coming in, so if people don't mind if we go a little bit over, we can handle those questions as well. All right, Chris, take it away.
Sure, I will go quickly then and get through as much as quickly as I can here for everyone. So thanks, Niteen and Glenn, for the invite. I think it's a great use case and a story, and especially when you think about an industry like this using IKS. So what I want to do is come give a quick overview and introduction to what is IBM Cloud Kubernetes Service and some of the things that we're doing on the IBM Cloud. So this offering is actually celebrating our 3rd birthday this month. So we're really excited about, and we've been building IBM Cloud on top of Kubernetes, where we're really focused on not only day 1 deployment of your cluster, where we stand up the compute, the networks, the storage on your behalf, but then also ongoing day 2 lifecycle management, meaning that you focus above the line, not there's a new operating system patch or vulnerability remediation or any component within the Kubernetes service stack. And it's great that we're building on open source tools, but the reality is that's very complex. So by using a managed service like IKS, IBM is going to provide that in those lifecycle updates. We're also very focused in IBM in general around security and workload isolation. So if you need to run bare metal as a part of your managed Kubernetes service, you can do that and extend your app's capabilities by using higher value services within IBM Cloud. So whether you want to add cognitive capabilities through Watson or adding weather data, because that impacts all of us, whether we're in travel or retail or other, to be able to have access to that data and make your app smarter and to be able to engage with your customers in a more meaningful manner is very powerful. And of course, the ability to run that cluster wherever you need. On the lower right-hand side, you'll see some CNCF conformance badges. Basically means that we're using upstream Kubernetes. You'll see here 1.18. IBM is the first public cloud service to add the latest and greatest. By working closely with the community, we're able to do that. And so when 1.18 comes out and is secure and operational and upgradable, then we make that available. Generally, it's a 0.1 or 0.2 release behind, but we announced last week 1.18.2. So this chart is very ugly, and it's intentionally done so, because when we think about what does a managed service mean to me, these are the things that IBM is providing. Again, thinking about raising that bar of responsibility. We want our customers, we want Niteen and everyone to be able to focus on solving their line of business objective. What do they need to help their customers or help them as an organization move faster, add new capabilities? So what are the things that IBM is providing? And we've talked about, the initial deployment, the ongoing lifecycle management to where we've simplified it. We notify you, so when you're ready to go to Kubernetes 1.18, you click the button, and then IBM takes care of the rest. And essentially what we do is drain all of the deployed pods from that first worker node. Once it's quarantined, we reload it top to bottom. Once it's online and healthy, we roll through the rest of the cluster. So it really simplifies that in a multi-zone cluster where we've got highly available masters. You are distributing that workload across different data centers or zones, therefore increasing availability, such that now if the API is being upgraded, my API endpoint is still accessible, or during an upgrade, the workloads are still accessible because I've got multiple instances running. Compliance is another thing. Compliance being a two-way street where IBM has some responsibility in things like HIPAA readiness and PCI and SOC 1, SOC 2, ISO, all the fun things that help kind of safeguard your data, your workloads to be able to run that regulated workload to the cloud. And of course, you have responsibilities to make sure you're using the right encryption, using things like HyperProtect services, which uses FIPS 140-2 level 4 encryption, meaning that your data is your data in IBM Cloud. Even as a managed service, we don't have access to it. So the couple of capabilities that we'll talk through quickly is around, that simplified cluster management. There's a beautiful UI you can point and click, but the reality is most users do that once, and then they drive that automation from the CLI or the API. We've talked about other services, things like being a native open source tool. So if you use the Cube dashboard on-prem in your laptop anywhere else, it's the same user experience. So once you've created the cluster through ICAS and the IBM Cloud Console, you have native tools, the same YAML, the same things that your building blocks, images would work consistently. And then the last thing is around integrated operational tools. So having a consistent monitoring and logging and DevOps tooling and security tools that sit at a higher level abstraction than within a given cluster. And that's a great thing to be able to run NeuVector, to have that operational security consistency, whether I'm running in ICAS or other clouds. IBM Cloud is built on Kubernetes. We've been doing this, like I said, for a long time. We've really standardized a lot of different services running on top of IBM, whether that's normal web-like applications like the console, to very resource-intensive applications like IBM Cloud Databases, all runs on top of IKS. This also allows us to bring in NeuVector to be able to run that. Let Kubernetes handle the placement and configuration such that if you auto-scale out worker nodes in your cluster, that ensures that NeuVector is running on those new nodes. A quick use case, obviously we heard one already, so here's another one that I like, and it's around Maersk. And the reason I like it is we're talking physical shipping containers using software containers to help achieve their business requirements, which is not about running software, it's about availability, so that way their customers can track where shipments are, when they'll arrive, very important things if you're running a manufacturing line. And one of the requirements was this 99.999% uptime, which basically means 5 minutes of downtime per year. So when they started, they were doing it themselves, and they migrated over to IKS while we were still in beta. And by architecting a solution that's running in multiple regions, that builds in that operational excellence. By default, in a multi-zone region with IKS, you're going to get a 99.99% SLA. So that's an industry-leading, financially backed SLA in our platform. But what Maersk is doing is rolling that in multiple regions with a global load balancer that sits over it. This chart's actually outdated. They've celebrated 3 years of 100% uptime. Yes, they've upgraded Kubernetes versions. Yes, there's been network blips and outages, but because of their architecture, they're able to achieve 100% uptime for their customers. A few things that we learned along the way. One is that we engage our users directly with Slack. Generally, we create private channels, so that way it's just customer, account team, my team to answer questions, point you in the right direction with docs or application architectures. And then the other thing is really about automation, automating everything. Most developers won't directly engage with Kubernetes clusters through running kubectl commands. They'll do so by integrating with their CI/CD tooling and having that automation in place. So that way, if it does fail a security scan, you can stop that train right there until you remediate it. The last thing I'll cover is that we take NPS feedback very seriously. If you're a user of IBM Cloud, you may have had one of these little surveys pop up, but we really do like the feedback. It helps us ensure that we're moving in the right direction with the value proposition, the things that we're building into the service. Like I said earlier, the focus is around simplified cluster management. Kubernetes is hard, so we want to make it as easy as possible. And some of the things helps validate that workload, ensuring that it is simpler to use Kubernetes in IKS. So with that, again, I wanted to blow through to try and keep us on schedule, and we'll see, Glenn, if we have any other questions.
Great. Thank you so much, Chris, for that overview of IKS. Yeah, let's just jump straight into the questions. Let's see. What is more important to you as an enterprise? Is it vulnerability identification or proactive blocking against threats? Niteen, do you want to take that one?
Yes, yeah. For us, it was a proactive, and then both are important, but proactive was much more critical for us, because what happens is that if you have that proactive, or you have those policies in place, and then other than, like, for example, if say you take your image and say goes in production, now it has 400 CVs, it's very difficult to chase or troubleshoot or get it fixed. So proactiveness was, at least in terms of this new world, it was one of our requirements.
Mm-hmm. Yeah, it sounds like you spend a lot of time automating the whole vulnerability management and alerting process, but ultimately it's to block these. The whole goal of everything is to block these attacks, right?
Correct. Yes. Yeah.
Yeah. Okay. What types of container workloads are you seeing in IBM Cloud? So that would be for Chris. I guess can you categorize, if at all, the types of workloads?
Yeah. So what's interesting is it's not industry specific. It really is a range of users that we're seeing, and really every type of industry. Everyone is building software in some form or fashion right now. I think there's quite a mix between cloud native projects. I think that's the predominant workload where it's just kind of easier to start developing a new project in this microservices-based and container world. But we also see a lot of app modernization, and there's a real spectrum of that, from repackaging as a container to completely refactoring that code to microservices. So it really is quite a wide and broad range.
Awesome, thanks, Chris. Let's see, where do you set up NeuVector in this overall architecture? Niteen, that sounds like it's for you.
Yeah, if I understand it correctly, so for example, we want a security tool for our containerized environment, irrespective where our clusters or container environment is running. Like, for example, it runs in IBM or in AWS or in future, say, Azure, whatever it is, we want a security tool which should fit to our containerized environment, which is enterprise level. So, if I answer correctly.
Yeah, I'll jump in a little bit there, Niteen. So basically, the NeuVector scanner that you saw, as well as the enforcer, is deployed as a daemon set on the worker nodes in every cluster, and there's a control plane for that as well. Now, you can choose to deploy just the scanner part in the build phase in your dev environment where your Jenkins is running or other tools. But I think in Niteen's case, you chose to use the cluster scanner to do the scanning because then the scan results could be tied into the admission controls, right?
Yes, that was a critical thing. For example, yeah, you can run your scanner or get all the scanning details outside your cluster. It's quite possible. But moment you want to use admission control, your NeuVector should keep all the data of your image scan results. If you scan outside NeuVector, you will not have that result, but you can use that to validate the image. So in our case, we want to make sure the developer has an option. They can run it just for whatever reason they want to do it. But our main goal was to scan inside so that NeuVector keep all the data and we can apply admission control as required.
Great, thank you, Niteen. What are some of the biggest challenges with running containerized workloads? I'll ask Chris to answer that, and then I don't know if Niteen, you want to talk about that at all. Chris, why don't you go?
Yeah, so from a challenges perspective, I mean, I think I touched on it briefly, that the fact that Kubernetes is hard, there's a lot of different options that you can select through your YAML definition and things like that. So I think kind of shifting the responsibility so you're focused, again, just on your app development is important. And then, probably the number one thing that I get asked when I'm talking to customers is around security. And how do I, in this new container world, which is new to a lot of people, how do I get that in-depth security view into these container packages, regardless of where I get the source image from, whether it's something I built myself or I pull from Docker Hub. And that's where you look at NeuVector really leading the security space to give you those insights before, to be able to put up that IPS or IDS type capability, or to get those insights into that content. I think that goes a long way to providing comfort from the CISOs within your company. So I think NeuVector is a great way to bridge that gap as customers are starting to move to containers and cloud.
Okay, thanks. Niteen, anything you would add?
Yeah, I can add. Yeah. So as a developer, you can develop the image using containers. It's very easy to do that. But to get that into an operational ready or get to at an enterprise level, you have to tie up all your security. You have to tie up all your endpoints. You have to make sure whatever you develop and is up and running in a secure manner is much more difficult than just developing your image. Like, for example, as a developer, I can go and get develop image. It's very easy to do. You can do it in 1 and 2 days. But tying up or making that environment safe, secure, it's kind of initial difficulty. Yeah.
Great, thanks. So you can see here, I think I'll wrap it up now. If you want more information on NeuVector, please contact us. And then Chris, if people want more information on IKS, where should they go?
Sure. I've got a nice short link, ibm.biz/IKS-Slack. Hopefully that's easy to remember. If not, my email and Twitter handle were up on the previous chart, so feel free to reach out in either of those manners.
Okay. Great. Well, thank you very much, Niteen and Chris, for a very insightful webinar. Exciting things that both companies are doing in this space. So thanks again. Thanks everyone for joining us. And we will be automatically sending out the recording after the webinar. All right. Have a good day, everyone. Thank you again.
Thank you, Glenn. Thank you, Chris. Thank you, Niteen. Bye, everybody.